Hi, everyone. So this will be our last video lecture for this week on synapses. And in this video, we're going to be covering hormones and drugs and basically how that all relates to communication among neurons and synapses. So let's start with hormones. As you guys may remember from our first quiz, one of the items that some people struggled with is the idea that hormones are related to biological psychology. Hormones actually do play a pretty big role in what happens to us and our brains. Hormones are chemicals that are secreted by cells in one part of a body and conveyed by blood to influence other cells. So one way that kind of helped this, that may help this click for you, is you may remember when we talked about neurotransmitters in the previous video. I put a little picture of a phone down here. You can think of hormones as kind of like more like radio waves. So this is kind of like an image of some, the signals from a radio station coming out. So basically anyone tuning into that channel will receive the message. So hormones are kind of like that, more so than a telephone, because they're helpful for long-lasting changes. So that chemical may be secreted and basically get to different areas of the body so that all of those different areas that need to receive that message can receive it. We have two types of hormones, protein hormones and peptide hormones. And a big key player when it comes to hormones is our pituitary gland, which you may remember is of the brain. We've got the anterior pituitary and the posterior pituitary. The anterior is composed of glandular tissue, and it synthesizes 6 hormones, but the hypothalamus still controls when those hormones are going to be released or not. And the posterior is composed of neural tissue, and it synthesizes oxytocin and vasopressin hormone. So this is a quick look. It's a diagram from our book, figure 2.20, and it basically gives us a snapshot of the different locations of endocrine glands. So, and the hypothalamus is still kind of calling the shots when it comes to different hormones being released from the pituitary. And these are the different areas of the body in which we have glands that are going to be impacted by hormones and ultimately part of the endocrine system. We've got parathyroid glands, thyroid glands, the thymus, our liver, adrenal gland, kidney, pancreas. We've got our reproductive glands, which is the ovary in females and testes in males, and then the placenta in female during pregnancy. So all of those are associated with hormones, respond to hormones. Here's a quick look, a little bit closer at what we were talking about earlier, the pituitary gland. So we've got our anterior, which you may remember means closer to the front of our body, and then the posterior, which means closer to the back. So here's our anterior and posterior lobes of the pituitary gland, just to kind of give you a visual of what we're talking about there. And as we discussed in the earlier section, the hypothalamus is still very much involved in kind of what's going on. Okay, so here's a really great table, table 2.4 in chapter 2 of our book. And it talks about each organ that is associated with hormones, which hormones that they are associated with, and what those hormone functions do in part. So it's kind of a brief snapshot of what is involved, what hormones are involved with which organs, and it can really be helpful to reference back to this. Know that this is a really great table to reference back to talk about or to be aware of the different hormones that are related to our functioning. So the other topic I wanted to cover in this video that is covered in our chapter 2 of our textbook is drugs and how drugs can impact us. So drugs can impact us in several ways. Sometimes a drug will chemically resemble a neurotransmitter and can basically even bind to that receptor of that neurotransmitter. So for example, some hallucinogenic drugs can chemically resemble serotonin, so they can actually attach to the receptors, the serotonin receptors, even though they aren't actually serotonin. Since they have a similar chemical makeup, they can kind of mimic serotonin and attach to those receptors. There are some drugs for which we have actual special receptors in our brains. One example is nicotinic receptors. So people who use nicotine, actually there are receptors in the brain that are also related to dopamine that they will attach to. Some drugs actually block the reuptake of certain neurotransmitters. One example there is cocaine. When people use cocaine, it blocks the reuptake of dopamine. So therefore, it's leaving more dopamine kind of floating around because it's not being taken back up by the neuron. Let's take a quick look at this visually. This figure is a visual that kind of shows you the way that different drugs will work in regards to the communication between neurons. So the example that I gave earlier is how cocaine will block the reuptake of dopamine. So if you think of this as the presynaptic neuron, and this being here the axon terminal, and then this being the postsynaptic neuron, the dendrite of that postsynaptic neuron, when dopamine may ordinarily be taken back up by the presynaptic neuron, cocaine would block that reuptake from happening, therefore making dopamine more concentrated in the synaptic gap. So that's one example, and the book does describe in detail these different other examples that it's also showing, such as antidepressants, cannabinoids. So feel free to read over those other examples as well in relation to this diagram. This table here is a summary of the drugs that were covered in our chapter this week and what their effects are. So amphetamine, for instance, blocks the reuptake of dopamine and several other transmitters. And as we talked about just a little bit earlier, cocaine is doing the same thing. And so this chart, I really like it because it just gives you a quick little snapshot of what is the drug doing as far as synapse communication. So I'm not going to just read one by one each of these to you, but I wanted to reference this table because it's a really great one to help you become familiar with drugs and how they relate to neuron communication. So that is all I wanted to cover in lectures for this week. Again, some of the tables that I didn't read line by line, please become familiar with the information in those tables. If you have any questions, a lot of this information is pretty complex and abstract, so feel free to reach out with any questions that you may have. And I hope you have a really great week. Thank you.